Testing. Dengakin? Testing. Dengakin? Okay. Okay. All right. Good morning, everyone. It is my great pleasure to welcome all distinguished guests, keynote speakers, presenters, and participants to the Second International Conference on Environment Engineering, Urban Planning and Design, or Eeupd 2025. And on behalf of the organizing committee, I extend our sincere appreciation for your presence and support for this one-day international event. So we are delighted to bring together a diverse community of scholars who will share a common interest in advancing sustainable, resilient, and future-ready built environments. And Eeupd, the second Eeupd 2025, this year's conference theme, Accelerate Sustainability Through BEAM and Digital Innovation. It reflects the evolving landscape of environmental engineering and urban development around the world. And around the world, cities are facing unprecedented challenges related to climate change, rapid urbanization, increasing resource demands, and the need for more equitable and sustainable growth. And as we all know, these issues call for solutions that are not only technically sound, but also integrated, data-driven, and also collaborative. As we all know, environmental engineering today, it encompasses a wide spectrum of responsibilities, and it ranges from air, water, soil pollution control to waste management, and also environmental modeling. And simultaneously, urban planning and design have expanded their focus to include inclusivity, resilience, smart mobility, and the harmonious relationship between people and the built environments. And as our cities grow, more complex decision-making must be grounded in strong evidence and powered by advanced digital tools. And in recent years, digital technologies such as building information modeling or BIM, digital twins, geographic information system or GIS, and environmental simulation platform have reshaped the way we analyze, design, and manage infrastructure and also cities. And this tool allows us to understand environmental impact with greater precision, test alternative scenarios, optimize resource use, and forecast system performance more accurately. Importantly, this fosters interdisciplinary collaboration by bringing every party onto shared digital platforms, and digitalization does enhance the how of our work while sustainability continues to guide the why. And in order to support these ambitions, the Eeupd 2025 has been thoughtfully organized around 5 key thematic tracks. So the first track, it explores digital technologies for environmental engineering and urban planning, including digital twins, GIS integration, and also smart monitoring system. Our second track, it examines smart cities and urban digitalization, and it focuses on mobility, resilient infrastructure, and also urban governance. Our third track, it highlights the integration for sustainable practices across the building and infrastructure lifecycle. And in our fourth track, it addresses social sustainability and human-centered design, emphasizing inclusivity, equity, and also community well-being. And last but not least, our fifth track, it discusses the policy, standards, and education framework necessary to support digital sustainability across sectors. As part of our conference today, so we are honored to have 3 distinguished keynote speakers. Our first keynote speaker, who's going to deliver her keynote address shortly, is Professor Surveyor Dr. Karunita Binti Ali, who is currently the Dean of Faculty of the Built Environment and Surveying, University Technology of Malaysia. And secondly, we're also delighted to have Associate Professor, Architect Dr. Lim Yek Wah, also from the University of Technology of Malaysia. And our third keynote speaker is Prof. Muhammad Abdul from Institute Technology Bandung, Indonesia. Their expertise and insight will undoubtedly enrich our discussion and inspire new direction for research and also practice. I would like to also express my appreciation to the organizing committee, our scientific reviewers. Thank you for your contributing your ideas, research, and enthusiasm to Eeupd 2025. So before I end this welcoming address, so I would like to wish everyone a productive, engaging, and also inspiring conference. Now, as a continuity of the welcoming message delivered, I would like to now invite our first keynote speaker. And before I invite our dear Professor Surveyor Karunita Binti Ali onto the screen, I would like to briefly read her biodata. Okay. So Professor Surveyor Dr. Karunita Binti Ali is a distinguished academic and a professional quantity surveyor who currently serves as the Dean of the Faculty of Built Environment and Surveying, or FABU in short, at University Technology Malaysia. And with more than 20 years of experience in academia and research, she is widely recognized for her expertise in building information modeling, or BIM, digital construction, and information technology integration within the built environment sector. Our dear Professor Surveyor Karunita Binti Ali holds a PhD and Master of Science in Information Technology in Construction from the University of Salford, United Kingdom. And she also has led numerous grants focusing on BIM collaboration framework, digital twins, and also mixed reality safety applications. And today, we are honored that she's going to deliver her keynote address with the title, 5D BIM for Carbon and Cost Forecasting, Transforming Decision for Sustainable Projects. Therefore, please join me to welcome Professor Surveyor Dr. Karunita Binti Ali to the screen. Please welcome, Prof.
Thank you, Mr. Chairman. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. I wish I could switch on the video and you guys can see me, but unfortunately I have to change 3 times change my laptop, 3 laptops, and I couldn't get the video on. But I think you have seen me on that main poster. That is me. Thank you, Mr. Chairman, for reading out my biodata. So what my topic today is on 5D beam for carbon and cost forecasting, transforming decision for sustainable projects. Of course, the focus is on 5D, but when you mention carbon, maybe people will think this is the topic under sustainability, which is about 6D. But what I'm proposing in my keynote speech today is how we look at 5D beam for carbon and cost forecasting all together is in the same process. Okay, let me share my slide. So the host is allowing multiple presenter. Okay. Okay. Right. Thank you. Right. Can you see my slide? Yeah.
Yes, Prof. You can see
Thank you.
Yes. Okay.
Thank you. First of all, I'm honored to be invited as the keynote speaker. I would like to share some points of view of what we've been doing in the RG, looking at 5D beam. And basically what I'm going to present today is the framework that all of us in the RG looking into, which is the 5D beam in relation to carbon and cost forecasting. So this is the overview. I believe I have 30 minutes, yeah? Inshallah, I will deliver throughout within that 30 minutes. So we're going to have, I'm going to explain the cost carbon integration methods and then what is 5D beam and how is it enables cost and carbon forecasting. And we look at implementation challenges and Malaysia roadmap leading to the cost carbon forecasting and conclusion. I'm going to touch into the process of 5D beam, and also in relation to that, we're going to look into the value management or value engineering exercise as well. So globally, the construction sector is responsible for 38% of total carbon dioxide emissions. That includes both the energy used to operate buildings and the emissions from materials and construction. What important is this? According to KPMG, embodied carbon, which is the carbon from cement, steel, or aluminium, transport and construction, is expected to overtake operational carbon by 2040 if nothing changes. Here in Malaysia, our national energy transition roadmap commits us to net zero by 2050, which means we must address embodied carbon in every new project, not just focus on energy efficiency. And here's the critical insight: 70 to 80% of a building's lifetime carbon is already locked in during the early design stage. When we choose materials, the structural system, facade, and construction methods. Once these decisions are made, the carbon trajectory is almost fixed. This is why 5D beam is relevant, and I want to say powerful because it let us see the cost and carbon impact before design is finalized. So people often ask, why do we save 70 to 80% of carbon is already locked in during design? Firstly, material selection is made at concept design, and materials are the biggest source of embodied carbon. Concrete, steel, aluminum have high carbon factors. Timber, recycled steel are much lower. Once you choose the material palette, your carbon trajectory is essentially set. Secondly, the structural system is fixed also early. Steel versus RC frame, for example, precast versus in situ, modular versus conventional. These decisions determine the bulk quantities, which determine both cost and carbon. Thirdly, the building geometry, floor plan, number of basement, facade ratio, orientation, all these drive both material volume and energy performance. Once the geometry is finalized, it is extremely difficult to change later. And finally, late changes are expensive or impossible. as we all know, it will incur variation. After tender or during construction, you cannot suddenly redesign basement or switch from RC to steel. So the carbon impact is essentially set in the early design phase, which is why early stage 5D beam analysis is so important. What is 5D beam plus carbon? When we talk about 5D beam, we start with the basics, the 3D model itself, the geometry, the spaces, walls, structural elements, MEP system. And 4D adds time, linking the model to the construction schedule so we can simulate the sequencing. And 5D adds cost, quantities from the BIM model automatically linked to cost database, giving real-time cost updates whenever the design changes. Now, when we extend this into sustainability, in this context, 5D plus carbon means every material in the model carries a carbon factor, just like it carries a cost factor. So 1 kilogram of steel is 1.9 kilogram carbon emission. Okay, and 1 kilogram concrete is 0.12 kilogram carbon emission. And this is the carbon factor. So the same 5D bin that updates cost automatically can now also update carbon automatically. In a sense, 5D beam plus carbon equals to a single digital model where design, cost, time, carbon are all linked, giving instant feedback for sustainable decision making. And in BIM context, this is why 5D beam plus carbon forecasting is powerful. Because carbon forecasting gives us real predictive power. First, it allows us to test different design options while design is still flexible. At concept stage, we can simulate and compare if we switch from RC to composite, if we reduce facade glazing, if we use these social types of concrete. And secondly, BIM highlights carbon hotspots like steel heavy floors or oversized MEP system before they become expensive problems. Third, 5D BIM supports informed redesign. When carbon results come in, we can adjust layouts, materials, or systems in a targeted way rather than doing guesswork. In short, instead of reacting at the end, 5D BIM helps us optimize sustainability while the design is still changed. And let's have a look at this. These values represent the embodied carbon intensity measured in kilogram. I always confuse how to pronounce this. Carbon emission in per kilogram of materials. Embodied carbon refers to greenhouse gas emission, as you all know, generated during extraction, manufacturing, processing, and transportation. Okay, for example, here steel 1.9 kilogram carbon emission per kilogram. It is high carbon due to smelting and high energy use. In comparison to concrete, lower because it contains aggregates and water, but carbon increases when cement content rises. Okay, so the cost value in ringgit per kilogram shows the financial impact, and when paired with carbon intensity, 5D BIM enables material selection trade-off, carbon cost optimization, and life cycle forecasting. So these ringgit values or monetary values are typical market range users for demonstration. Okay, the one I put here is for demonstration purposes. It's not in practice. Material prices fluctuate frequently based on supplier, volume, region, procurement method. So the purpose of this slide is basically to show that cost per kilogram and carbon per kilogram are not correlated. So a low cost material may produce high carbon and vice versa. So how 5D BIM works plus carbon, yeah? Cost per kilogram shows how much we pay carbon per kilogram, okay? And how much we pay, but carbon per kilogram shows how much carbon dioxide we emit. When we combine this inside 5D BIM, we can compare materials not only by price, but also by sustainability. That is how 5D BIM guides better decisions. So here's how 5D BIM actually works behind the scene. Automated, number one, automated quantity takeoff from BIM model with BIM. every wall, the slab, column, or whatnot is has digital information. So instead of manually measuring drawing, the system automatically extract all the quantities accurately. And this is the foundation for both cost and carbon calculations. Yeah, and secondly, the second step is the linking BIM to cost and carbon data. So once we have quantities, we connect them to two critical data source, which is one is cost database that tells us the ringgit per unit, and another one is a carbon database that tells us the kilogram carbon emission per unit. When we multiply quantity plus cost times cost and quantity times carbon, we instantly get the financial and environmental impact of the design. And so on, simulating design alternative. And the power of 5D BIM is that when you change one design element, such as material type or structure system, BIM recalculates everything within seconds. And this allows us to compare multiple solutions and choose the one that offers the best sustainability value. And carbon cost trade-off dashboard, that's number 4. Instead of guessing, dashboard shows which option is cheapest or which option has the lowest embodied carbon and which option delivers the best balance. This transforms sustainability into a measurable data-driven decision. And the last one is AI-driven predictive analytics. So this is if we have enough data, we have enough good database, we can use AI, or we can adopt AI, we can develop AI, which AI can take past project data and simulate how cost and carbon change over time. And this helps us predict overruns, optimize materials, and select the design pathway that delivers long-term sustainability and financial stability. So actually, looking at this process, it is a process exercise in value management or value engineering. Okay, in fact, embedding 5D BIM, cost plus carbon, into a value management or value engineering exercise is one of the strongest strategic messages that I want to deliver here. Traditionally, value management focus on achieving the required function at the lowest life cycle cost. However, the definition of value has now expanded. It is no longer cost only. It must include carbon impact, resource efficiency, material lifespan, and sustainability performance. By integrating 5D BIM into VM or VE workshops, all options can be assessed quantitatively, not based on intuition. BIM provides automatic quantities, material properties, carbon factors, and cost implications. So instead of debating opinion, the team evaluates data-driven alternative. So 5D BIM turns value engineering into value optimization, because every material, every element, and every decision can be evaluated on two axes simultaneously, which is cost and carbon. And this means the VM of workshop becomes more objective, transparent, and aligned with sustainability performance. So the flow I showed in this slide shows embedding how we embed 5D BIM into the VM or V engineering. So I call it the flow. Okay, let's look at the first one. Okay, why these steps? The basic BIM model authoring process. Why this step matters? In traditional VM, function analysis is based on drawings and assumptions. With BIM, function analysis become data-driven and visually accurate, eliminating guesswork. So BIM makes function analysis no longer theoretical. We can see the functions, systems, and conflict clearly in 3D, which give VM teams a more reliable baseline. And the next one is baseline automated QTO or quantity takeoff for baseline. Okay, it generates, BIM automatically generates exact quantities of materials, so we can get accurate baseline cost and baseline carbon using material carbon factor. So why this matters? VM decisions require accurate baselines. Manual quantity takeoff is slow and error prone, and BIM ensures zero duplication, real-time updates when the design changes, and one source of truth for cost and carbon. So without the correct baseline, VM lacks credibility. 5D BIM gives us a reliable snapshot of cost and carbon before any value options are explored. The next one is the generate alternative option. We develop options like using composite materials or modular MEP. So the process, it gives alternative design strategies. Why this matter? VM is ultimately about options. BIM allow options to be generated faster, explored deeper, and evaluated objectively. Instead of debating options verbally, BIM allows us to propose realistic alternatives based on quantifiable data. And the next one is 5D BIM evaluates the options. Why this matter? Why VM decision becomes data-driven, not based on intuition. It helps avoid value cutting and ensures value improving. And this is where the magic happens. Every options we test is automatically recalculated for cost, carbon, and time. And we can compare options in minutes, not days. Okay. And next, VM team selects best value options because VM is not cost cutting. VM is maximizing value across 4 metrics, which is function, required function, performance, lowest cost, and lowest carbon. So 5D BIM give the team a transparent cost carbon matrix, and the best value option is now defensible, measurable, and aligned with sustainability goals. And the last one in the flow is to document the VM decision. Is it important? Yes, VM decision making must be defendable. 5D BIM provides evidence for audit trail, client approval, sustainability certification, okay, like any green index tools or QS validation. So with BIM, our VM report becomes evidence-based. Every value decision is traceable, transparent, and quantifiable. So, and this document become formal VM justification. So, talking about AI, yeah, that's the flow. But talking about AI, where do AI can be useful here? So, I draw the flow, the number step 1 till 6 just now, and I show here AI integration point. Okay, the point is number 2, number 4, and number 6. Okay, there's a little bit explanation with white font, white font. Okay, so the number 1 is AI integration point. Number 1 is after step 2. After the automated quantity takeoff. Okay, so once the baseline, this is the AI for pattern detection and design risk insight. Okay, once the baseline cost and carbon are extracted, AI can immediately analyze the BIM model to detect patterns, oversized structural members, unnecessary MEP complexity or facade element with poor thermal performance, for example. So this helps the VM team identify where the true value problems are before we even start generating options. So AI adds value here by identifying design inefficiency, highlighting high carbon hotspots, suggesting typical areas where similar project had cost overruns, and predicting elements most likely to contribute to waste. So secondly, within step 4, okay, AI integration point 2, AI for multi-scenario simulation, yeah. Beyond manual scenario simulation, AI can automatically generate thousands of design permutation and rank them based on cost, carbon, and schedule impact. So instead of VM team testing only 3-5 options, AI can analyze 300 or 3,000 options and shortlist the top 5 best value ones. So we know, I think at this point of time, everybody knows what AI can give to us in terms of the data, in terms of the decision generated by the system, by AI, and things like that. I'm very sure the next 3 years, 5 years, if this is in place, we can have more than just 3,000 data. So AI add value where AI adds value here by multi-scenario simulation, automatically optimizing material combination, suggesting alternative system, for example, modular steels or hybrid slabs, and etc., and running carbon cost optimization simultaneously. So, VM moves from human brainstorming to AI-supported exploration. Another one is at step 6, okay, documentation and validation, where this is AI for life cycle prediction. Finally, AI can predict long-term impacts for each chosen VM options, life cycle carbon, maintenance frequency, what else, operational energy, and even probability of cost overruns. So this ensures the VM recommendation is not only cheaper today, but cheaper and greener over 30 or 50 years time. So AI adds value here by predicting operational carbon, not only embodied, and forecasting maintenance and replacement costs, warning if a cheaper design creates higher lifecycle costs, generating automated VM justification reports with charts. And this elevates VM from short-term saving to long-term value optimization. In summary, we embed AI at 3 points. First, right after the baseline quantity takeoff, where AI analyzes the BIM model and identifies cost or carbon hotspots, guiding the VM team to the right issue. And next, during option evaluation, AI can automatically simulate hundreds of alternatives and shortlist the best value ones based on cost, carbon, and time. Finally, AI predicts long-term performance, life cycle carbon, maintenance need, and potential cost overruns, ensuring the VM recommendation delivers value, not just today, but across 30 or 50 years of asset life. So instead of VM being qualitative, it becomes a data-driven, evidence-based optimization process powered by 5D BIM plus AI. So what is the challenges? Some of you might say, this is too good to be true, maybe, or has it been placed? Of course, everything start with the first steps, there's still a lot of challenges. Okay, number one, lack of Malaysia specific carbon data set. So in Malaysia, we do not yet have a, okay, there is, okay, but to be fair, the national standardized embodied carbon database that we have is, there's a lot of reference to overseas data such as ICE UK or One Click LCA EU, I think from Australia. Okay, that is the reference. So we need to have our own nationally standardized embodied carbon database. So we have embodied carbon inventory data for construction materials, and also there's another one which is launched in May, something score. Okay, it remains not fully comprehensive. Okay, it has about 500 records in it. Okay, but I'm sure from time to time it will be increased, and I want to say they are working on it. Okay, but we need those kind of data. Okay, because in our context, our researchers still use, we rely on foreign database. Okay, we still rely on foreign database. I do not have data on how many researchers refer to the CIDB embodied carbon inventory data. Okay, maybe we could look into that. I believe that CIDB, this thing is year 2021. Maybe they have the latest one, I'm not sure. But it is important that Malaysia have our specific carbon data set, because it has, we need carbon data set that refers to our context. Okay, and next challenges is lowest price procurement cultures, which is lowest cost wins. So our current procurement system, especially in public sector project, say prioritize the lowest price rather than best value. We try to get that best value, but what I'm saying here is we could optimize the use of 5D BIM plus AI so that we could get the true best value. And so because of this, it discourages contractors and consultants from proposing low carbon alternative, because these options sometimes involve a slightly higher upfront cost. So as a result, carbon reduction is not rewarded, and long-term savings like maintenance or life cycle costs, resource efficiency are ignored. This is a major barrier to adopting 5D BIM for sustainability. And number 3 is siloed teams. QS versus sustainability consultants. So in many projects, the QS handle costs and the sustainability team handles carbon. It's always like that, okay? And they rarely work in a common data environment. So maybe there is, but in my data, in my informed document, I do not get that. Okay, QS teams traditionally focus on ringgit and the cost and BQs, while sustainability team focus on the index, green index. There are many green index. Okay, so they are focusing on that. And without integration, cost data and carbon data, they don't talk to each other. So 5D BIM requires these two worlds to merge. Cost and carbon must come from the same model, updated by the same decision. Number 4 is limited 5D skills in the industry. So many QS and engineering professionals are familiar with BIM in 3D and some in 4D, but very few can fully execute 5D cost modeling, and even fewer can integrate carbon forecasting inside BIM. Okay? So there is a skill gap in carbon factor application, model-based cost estimation, and then using BIM as a decision intelligence tool also, we are lacking in that. Interpreting 5D dashboards, and all this slows down industry-wide adoption because teams cannot leverage BIM beyond visualization. So the fifth one is fragmented software ecosystem. This is, we have known this for a long time, okay, how the software environment is fragmented. Different organizations use different platforms, even for QS, we have Revit, but seldom we use Revit. I'm a QS, all right, and then we have CosX, because Gordon, then we can use simulation, Nevis work for simulation, and also various carbon calculation tools, but they do not integrate smoothly. And this means data is to be exported, reformatted, or manually edited between systems, causing errors and delays. Until we achieve better interoperability, the full power of 5DB for cost carbon forecasting cannot be realized. And this is a suggestion of Malaysia roadmap. Yeah. The first one is to mandate, this suggestion, okay, it could be controversial. Mandate 5D BIM for public project. I just put the 50 million ringgit there. When government project above this 50 million adopt 5D BIM, standardize the industry. Why 50 million? Because these are usually large, high impact projects with big carbon footprints. By mandating 5D BIM, the government forces the integration of cost, schedule, and carbon data from day one. And this single policy will immediately drive consultants, contractors, QS firms to upgrade their digital capabilities. So in terms of impact, higher data consistency, fewer variation, measurable carbon reductions, and better financial control. Next is develop a national embodied carbon database. As I mentioned just now, we do have, but we need to have carbon cost material passport for Malaysia. Okay, it is important because in our context is different from the UK, the Europe, or Australia. Okay, it is not accurate for our materials, climate, energy mix, or production methods. This is different. We need to have our own, and it has this national database where each material has local carbon factor, local cost range, local supply chain emission, right? So it becomes a material passport that 5D BIM can read. So it enables precise forecasting, benchmarking, and impact-wide transparency. Next is train QS engineers and architects in carbon cost modeling. Okay, we are talking about not just carbon for sustainability, not just cost, it's together, carbon cost modeling. So most professionals are trained for cost estimation, but not carbon estimation, right? Or the other way around, right? We must upskill the entire ecosystem, QS, designers, project managers, so they can read and interpret carbon data, create alternatives, and make cost carbon trade-off. As I mentioned, as I put forward just now about value management or value engineering, it is a process that could be part of the design process in order for us to identify options. So universities and industries should co-create modules on 5D BIM, carbon databases, material benchmarking, carbon cost optimization. And this will impact, this builds national talent pipeline, reduces dependencies on foreign expertise, and raises industry readiness. Next is require carbon disclosure in tenders. Okay, this is procurement. Okay, we don't have this. Okay, we could have any green index tools linked procurements. Okay, today tenders focus on the lowest price, majority. Okay, of course, look at value. But at the end of the day, we look at the lowest price, and carbon is quite invisible. We must require bidders to disclose embodied carbon alongside cost. This is not asking for the lowest carbon bidder to win, but to make carbon visible and comparable. So once transparency is created, procurement agencies can introduce green index scoring, where part of the evaluation includes sustainability performance. So this will move Malaysia away from the damaging lowest price wins culture, encourages innovations, shift market behavior. And last but not least, okay, to fund pilot projects using 5D carbon dashboards. So we can't transform the entire industry at once. So we start with few flagship pilot project. I think within JKR, when we start the BIM projects, they move the pilot project first. Okay, and we can see JKR have lots of BIM project nowadays. So maybe just identify a few flagship pilot project for 5D BIM, 5D carbon dashboards. And this dashboard shows live cost, live carbon, design alternatives, trade-offs. Okay, the lesson from this pilot will help refine policy and scale best practice. Okay, the impact of this, it will produce, the process will produce real data, real outcomes, and create industry confidence before nationwide rollout. And well, the conclusion, we cannot manage what we cannot measure. Okay, and 5D BIM gives us the transparency we need, linking cost, carbon, and design in one integrated model. As we move forward, let us commit to predictive, responsible, and climate conscious construction, where every decision is informed, measurable, and aligned with a sustainable future. With that, I thank you. Actually, I have a meeting after this. If you need to contact me, that is my email, and that is also my phone number, which is also a WhatsApp point of communication. So you can also WhatsApp me. So that's all. Thank you again to the organizer for inviting me, and thank you all for listening to my presentations. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Prof. Survey Dr. Karunita binti Ali. And we have one question from the audience. Maybe I just read this one question. Hopefully, Prof can answer this question.
I'll try.
Yes, maybe a short one, Prof. There's one question from Afiq Shazwan, and he was asking, how can we promote sustainable materials, either to be produced or used by industry players in construction project?
Wow.
How can we promote?
How do we promote? How do we promote? I can see from the government side, when for the past 10, 20 years, whenever they want to implement something, they have these roadmaps, within that roadmap, they have targets. And in Malaysia, it's usually, things get very efficient if it is a top-down solutions. Okay, top-down solution to promote. Look at IBS, for example. They set targets for 70%, 80%, 90%, and give rewards and things like that. So along the way, people opt for IBS. Okay, and although the constraint is always cost, but then it helps to reduce labor intensive process. It helps the cost as well, actually, in terms of long term for the contractor, actually, and then for the manufacturing industry and things like that. So I always believe, in Malaysia context lah, I always believe top-down solution is always good. So if from the government side, CIDB or JKR or the KKR can kind of like what I suggest just now, mandate it, okay, it will somehow rather keterpaksaan itu ada akan wujud. Okay, so people will slowly adopt and familiarize with the process, familiarize with the existing materials, familiarize with the KGCO2E.
Yes,
So
yes.
at the moment, we kind of not ignore, we just, because there's no pushing factor.
Mm,
No
mm,
pushing factor. So if that is in place, inshallah, we don't need promotion. People just doing it organically.
yes.
Organically.
Yes,
Yes.
Prof. We are running late by two
Yes,
minutes
yes.
now. Yes.
Yep.
It's a very interesting discussion that we might have in terms of embedded carbon, value
Yeah.
management, and also 5D BIM. I think this is a new area that we all could explore, and perhaps there'll be
Sure.
more discussion on this particular thing. Thank you, Prof.
Sure.
Thank you again.
Thank
Thank you
you.
again for
Thank you.
your excellent keynote,
Thank
and
you.
thank you so much, Prof.
Thank
Okay.
you. Assalamualaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Okay. To continue with our program today, I would like to invite our next keynote speaker, and our next keynote speaker is Associate Professor Dr. Lim Ye Wah. So Dr. Lim is currently an Associate Professor of Architecture and the Head of Architecture Department at the Faculty of Built Environment and Surveying, UTM. And he also a registered professional architect with the Board of Architects Malaysia, and also he's also a certified green building consultant. And his expertise includes sustainable architecture, day lighting, building information modeling, BIM, and building performance simulation. Dr. Lim has led several interdisciplinary research and also consultancy projects, and has authored over 100 publications in leading journals and also conference proceedings. Dr. Lim also the author of the book Tropical Day Lighting for Working Environment, and today he will deliver his keynote with the title Designing for Sustainable Future with BIM. And therefore, please join me to welcome Associate Professor, Architect Dr. Lim Ye Wah to the screen. Please welcome Dr. Lim. Thank you.
Thank you very much, Dr. Hadi, for the introduction. May I share my screen?
Yes, yes, Dr. Lim.
Okay, can you see the screen?
Yes, yes, we do.
Okay, very good. Very good morning to all the audience. First of all, thanks for inviting me to give this speech. The topic is about designing for sustainable futures with BIM. So we know built environment is bringing a great impact on the climate. Like it or not, every buildings that we build, we consume carbon. Okay, so that's why it's very important for us to build a sustainable built environment. So when you're looking at a building industry, it generates as much as 30% construction waste and expected to reach about 2.2 billion tons of waste annually worldwide. So it's a great amount of waste that is generated in the construction industry, and also consume about 36% of energy use and contribute 39% of energy-related carbon dioxide emission globally. So this is something that for all of us in the profession of built environments, we need to look into this seriously, because this is about our climate, is about the future of the worldwide. Okay, if looking at this, even though there's different kind of green building assessment has been established, but if no further action taken, it's expected the energy use it will continue to surge by 50% by 2050. So we have to do something. But we look at building life cycle. The carbon emission does not only happen during the construction. The construction only consists 10 to 15%. But during the operational and maintenance stage, there's about 75 to 80% of carbon emission. And even after that, during the demolition or refurbishment stage, there's another 10 to 20%. So when we want to build for a more sustainable futures, we need to look into the entire building life cycle, okay, from the design, construction, until operation, until even demolition or refurbishment at the end. Because our design decision at the beginning of the project will contribute very much to the operational stage, which is about 75 to 80% of the carbon emission. And building industry is considered one of the most inefficient or wasteful sectors compared with other industry where they have adopted more advanced technology in terms of sustainability. That's why BIM, Building Information Modeling, has been recognized as a platform for sustainable or integrated building project design and delivery. So BIM is a platform where every parties in the building industry, including architect, QS, engineers, facility manager, sharing the same platform for information so that we can optimize the design. And the benefits of BIM, including, of course, better collaborations, enhanced performance, and also optimize solution and faster project delivery and reduce wastage. As just I mentioned, there's a great amount of waste from the construction industry. And if you look at the photo, the image on the screen, there's a BIM model of my office in the faculty. Looking at BIM, I think most of us are familiar. There are 3D, 4D, 5D, 6D, and 7D, like just now mentioned by Prof. Karanita, about 5D BIM, which is for cost estimation. And 4D is about scheduling the time. But today I want to focus more on the sustainability, which is the 6D BIM, okay, which is using BIM as a sustainability design and analysis tools. For example, then go for green building certification like LEED, GPI, Greenly, and so on. And BIM, we have the different kind of level of developments. Like in the conceptual design stage, we call it LD 100, where it's just a very approximate geometry, while LD 200 is more schematic design, and 300 with more precise geometry. 350 is for tender coordination, 400 during the construction and fabrication, and 500 is as built. So today I want to try to show that how LD match with the green building design process using BIM. Okay, we know in a project design, not only the conceptual design, we have schematic design development, tender and coordination, construction, as well as build. So at the LD 100, that means that the BIM model is just a very conceptual massing. Okay, even without any openings, any structure, any facade design, it's just a massing. So at LD 100, we can use the BIM to do conceptual form massing, orientation, and site context analysis. The performances related to 6D BIM, like site analysis, solar study, macro wind flow, building form optimization, and green area. While at the LOD 200, where we have the form and facade, solar shading, and we have a more approximate geometry, then we can do the solar study for shading devices, daylighting, natural ventilation, and even zoning of the spaces. Then remember, at the early stage of the design, actually any decision or any changes will have a high impact on the performance, but very minimum cost implication on the design changes. So if we make the decision right at the beginning, then it will determine how the building operate or perform later on. Okay, compared with at the later stage, if you want to change the design, then it will require a lot of variation order or even demolition, okay, or reconstruction of the building. At LD 300, where we have more precise geometry envelope and even material specifications, then we can run the energy analysis, heat gain, or even OTTV, overall thermal transfer value, or IETV analysis, lighting, predicted main woods, PMV, and embodied carbon and operational carbon analysis. While going to 350 is more detailed, where we can run the 4D or 5D BIM analysis. We look into the energy and cost and value engineering. And looking at LD 400 during the construction stage, that's where we can even use BIM to study the logistic, the clash detection, to minimize the waste, and go for green building rating final evaluation. That is about another 10 to 15 percent of carbon emissions during the construction stage. While at the LD 500 to 600, which is as-built or the operational phase, then we can look into the life cycle carbon emission, the post-occupancy evaluation, and continue to monitor the building performance using BIM. And that accounts for 75 to 80% of carbon emission. But remember, at the design stage, even at LD 100, 200, that will contribute a lot into the operational phase. So here actually sum up how we can use BIM throughout the different stages in the project life cycle to do different kind of 6D BIM analysis in order to design for more sustainable futures. And these are just some examples of 6D BIM tools. For example, the IES, Design Builder, or Revit. And this is the workflow of 6D BIM, where we can export the model from the BIM modeling to GBS ML and import into some of these sustainability analysis tools for thermal analysis, visual, or energy. Just some quick examples of how we can do solar analysis um, using BIM model compared with the actual constructions. And these all these are real projects where we did even thermal analysis on how the shading, where the placement of the photovoltaic panel on top of a mosque building, which has been completed. And this is another example of using BIM to simulate the lighting, the day lighting in the apartment building. And this is how using lighting analysis to determine the impact of these skylights. And based on that analysis, we decide where to put the skylights, and it has been actually constructed. And this is another example of using CFD to see the macro wind flow and also the PMV thermal comforts in the buildings, and this energy analysis. Okay, next I want to talk about some of the research on BIM for sustainability. In our research team, we look into green building evaluation, BIM, BIM, and also computational algorithm. So we try to integrate these three aspects into our research, where we start with the BIM model. Then we extract the information from the model using Dynamo, which is a visual programming software. And then we input into the MATLAB using NSGA2 optimization algorithm, which is a genetic algorithm, okay, for optimization. And then with the optimized result, we push back to the BIM model using Dynamo so that it automatically updates the BIM model. So this is an example of the workflow that we have done in the Dynamo as a visual programming tools, and the example of model that we've done in Revit. And with one click in the Excel spreadsheet, because it's linked with the Dynamo, so all the information related to the building facade, the U value, the VT, all these are captured automatically with one click. And all these info are extracted from the Revit model. And from there, we can use it to calculate the green RE, the points for the OTTV, and straight away you can get to see that where is the amount, I mean the point for the RETV, okay? So this how we can use BIM for information management and extract the data to do calculation or analysis so that we can automate or simplify all this process for green certifications. And this is a real case example that we have done in as my building, my office building in UTM. And this is where the BIM model has been constructed. And then we use that workflow to optimize the facade design. We come up with two scenarios. One scenario is that we want to optimize window only, and the variation of the window area increment or decrement was limited to 20% variations. It means we don't want the building envelope totally change. We don't want to enlarge the windows too big or too small. Okay, so we kept it as 20% changes. And the second scenario, we not only optimize the window, we also optimize the wall by changing the wall materials, the insulation, and so on, in order to achieve the OTTV compliance with the Malaysian Standard 1525, which is below 50 watt per meter square. So these are the results from the optimization scenario 2. On top is the before optimization. Below is the after optimization. So the OTTV from 48 watt per meter square has been optimized to 25 watt per meter square, and the investment cost is about 96,000. Okay, this is based on the material cost and also the material specification that we input into the BIM model. Then we further study with other case study buildings, for example, the TRX Project Unity Tower in KL, and we're using the similar workflow, but we're not only looking into the OTTV, but we also look into the BI performance by including, of course, OTTV is included, but we also look into the energy performance and also the materials assessment. Like for example, in GPI, there's a criteria on the recycled materials. There's a criteria on the use of components of these regional materials that within the local industry. So there's where we can do material take-off in the BIM Revit. We created the schedules for material take-off. Then from there, we calculate using Dynamo, then we input the calculation into the Excel spreadsheet in order to give the results at how many score they can score in the GPI. Then to further explore this research, there's another project that is funded by the Ministry of Higher Education under PRGS grant. Then we not only looking into Dynamo as a visual programming tools, but we go into our own programming to develop a plugin, an add-in into the Revit. Okay, in this project, we come up with a BIM model. And then with the templates, like the RTE, RFA files, then we automate the data extraction and process. Then we created a plugin, a Revit add-in we call BIMJazz, in order to automate the process to evaluate based on the green RE criteria, NRB 1-1 OTTV, 1-3 building envelope, NV, MV, daylighting, and electric lighting. And then we link it with a website with a database where the users actually can download the templates and also the material properties. Where we have the library, for example, the users can download the Windows library, the wall material library, and so on. Basically, all those are the RFA file, the families file in the Revit. And then again, if you automate the pushback of the optimized design into the Revit model. This Revit, this add-in we developed using Python programming, okay, rather than using VPL. This so that we can develop an add-in that we can install into the Revit. This is the example I want to show in the video. So the example of a model that has been developed in Revit. Then this is the add-in we have created and installed into the Revit. And this is the user interface where it will automatically detect the scenario of the building design, whether it's a aircon or non-aircon building, based on the zoning that you have modeled in the Revit. And then from there, we can detect is there any interblock shading from any floors. Then click next. Then if you do model checking, you can see that all the walls that has been detected has been highlighted in different colors to represent different orientations. And then straight away, if you give all the results of the OTTV just with one click, okay, and you will tabulate all the results for each floor, each orientation, and it can be exported to the Excel spreadsheets. Because when the green building consultant need to submit for green certification to green RE or GBI, they need to tabulate floor by floor. So we customize the reports to suit to the formats to tabulate all these calculation floor by floor. But all this, actually, the user do not need to do it by themselves, just a few clicks. But not only that, in the step 4, we can even optimize it using NSGA tool. Then we can optimize the composition of the different kind of building materials or window sizes in order to reduce or achieve certain compliance. In the optimization mode, if you can see on top there, it can be go for minimize OTTV, and cost or certain target OTTV. And it can run different population and mutation rates and how many times of iteration, and also set the Windows area tolerance. So with the optimized result, the user just need to click it. Okay, just need to click any composition of that, and it will shows all the details. And not only that, it's also give the cost, the estimate costing. But of course, the estimate costing is based on the library or the info we key into the Revit model. Okay. The video is a bit long. But what I'm showing here is that actually you can add, because in NSGA2, every time you optimize, it will generate different solutions. So you might optimize a few rounds, but every time when this is generated, you can add the optimized result into a safe result at the left bottom here, so that we can always refer back later on. Okay, I try to skip the video a bit. So this is how we can actually look into the changes. It will tabulate all the original and also optimize, and we can click show. So it will show in the 3D model which part has been optimized, which part has been changed, and what are the materials. All these materials, of course, are based on the libraries that we have in the Revit model. Okay, and not only that, we can export into Excel spreadsheet, and it will give the results. Like just now was the OTTV. Now I'm showing the building envelope. This is like how many percent of west-facing facade, 10% of the west-facing window is shaded with shading device, and all this will automatically calculate the points, and we can export into PDF file that can be submitted for the green certifications. Okay. So from here, we are exploring the potential of using BIM and also programming algorithm to optimize the design, not only evaluation, but also to do design optimization, and then can generate the reports and go for green certifications or any design report that can be generated. And the good point here is that all the optimization can automatically push back into the Revit model, and it will update in the model for design evaluation. From here, you can see we also have developed a website, greenbest.com, where the users can register themselves and download the software, download the Revit add-in, download the library, and test the tools. And we collaborate this with our industrial collaborator, Green RE. Okay, to conclude my talk this morning, firstly, we know sustainable design requires integrated design and collaboration from different team members in the building industry, okay, including architect, engineer, QS, even the landscape planner, project manager, and even the contractor. Because the entire building life cycle is complex, okay, so it's important for us to have a shared platform or a unified platform for every parties to have the same information and to have good coordination in order to optimize the design and also to evaluate the performance. So what I presented in my research are some method of using computational BIM, okay, to provide a higher level of automation for green building design decision making. Because as the consultant or designer, a lot of time we need to make informed design decision making. But to do all this calculation will takes a lot of time. Like just now, I show you a few clicks, but without this automation, that will might consume a few days in order to do all this optimization. But with the integration of BIM, VPL Dynamo or MOO, multi-objective optimization, and SGA2 in the MATLAB, or later on, where my research team start to using Python to develop the Revit add-in, it can actually automate and speed up the process. So when the process has been speeded up, I believe that will encourage more takers look into the green or sustainability performance in their design process. Because now many designers might say that it is very time consuming to do all this analysis. But with the use of BIM and computational algorithm, actually all this can be even more effective. And BIM is a platform that can provide a centralized database to optimize for the project design and delivery. That's all from me. Thank you very much.
Thank you so much, Associate Professor Dr. Architect Dr. Lim Eeupd. And from my understanding of the keynote, the points lead us into the future of sustainable design, where BIM becomes a powerful catalyst for smarter planning, resource efficiency, and low impact development using the power of automation. And much specifically from what we heard from Associate Professor Dr. Lim just now, the use of computational BIM-based method. I think this keynote show how digital design intelligence can guide us towards more resilient, sustainable built environments. Well, actually, we have one question in the chat box, Dr. Lim, but since we are trying to stick with the time, so perhaps we could come back to the question later if the time permits. And again, thank you very much, Associate Professor Dr. Lim Eeupd, for the excellent keynote. Thank you, Dr. Lim.
Thank you.
All right. Okay. Now, to wrapping up the keynote session, I would like to invite our third and our last keynote speaker. And for that reason, I would like to invite Professor Muhammad Abdul from Institute Technology Bandung, Indonesia. And let me briefly introduce you to Professor Muhammad Abdul. Professor Muhammad Abdul is a professor in construction operation management at Faculty of Civil and Environmental Engineering, Eeupd. So he was the vice rector of for finance, planning and development of Eeupd from 2020 up until 2025. And from 2018 to 2020, he was the head of civil engineering undergraduate program. Professor Muhammad Abdul received his PhD from Purdue University, United States in the year 2000, and his research interests are in procurement, logistics, supply chains, productivity improvement, lean construction, simulations of construction operations, sustainable construction, ICT application, and also infrastructure management. Well, in a career spanning over 25 years at Eeupd, he has developed deep links with industry and also government, and constantly inspiring the Indonesian industry to adopt new concepts and technology. Prof. Muhammad Abdul is also currently the chairman of the Indonesian Professional Association in Lean Construction Management and a member of the Board of Ethics of the Indonesian BIM Institute. And today, I would like to welcome Prof. Muhammad Abdul, and he will deliver his keynote address, with the title Lean Construction, the Way to Deliver Sustainable Infrastructure. And therefore, please join me to welcome Prof. Muhammad Abdul to the screen. Please welcome, Prof.
Okay, thank you, Pak Samsul.
Welcome, Pak Abdul. Nice to see you.
Can you see my slides?
Yes, yes, Pak Abdul.
Okay, so good morning. Assalamualaikum warahmatullahi wabarakatuh. So,
I think you have to change the first screen because we are
okay.
Presenter view.
Okay. Wait. How about this?
Yes, you can try.
Okay.
Yes, correct. Thank you, Pak.
Okay. So,
okay.
Yeah. Good morning. Assalamualaikum warahmatullahi wabarakatuh. So, it is my pleasure, and also it's an honor, for me to be invited to talk in this conference, Thank you, Pak Samsul Hadi, for inviting me. I would like to continue, our discussion this morning. Before, I think the two keynote speaker already talked about how to design, also to simulate, what's called the achievement of the sustainable infrastructures, mostly related to BIM technology, So I think my questions, I think, and also the motivation of this talk. How can we deliver that kind of very specific specification and very, I think, high performance that we need to achieve here in what's called the sustainable infrastructure. So I would like to propose what's called lean construction as the way to deliver sustainable infrastructure. So this is my talk, yeah, on only 3 portion. Maybe we just review a little bit about the sustainable infrastructure. In the context of Indonesia, I think we need to also introduce what's called the resilient infrastructure, instead only sustainable infrastructure. Also, I would like to introduce what is lean construction, and also at the end, I would like to describe how lean construction can deliver sustainable infrastructure. Okay, as we know, sustainable infrastructure coming from the understanding that sustainable infrastructure should be designed, construct, operate, and also decommission in what's called the environment, economy, and society criteria. Yeah, I think in 1987, I think Ms. Berntline already mentioned about that, and I think we agree on that, and we try to adopt to many kind of sectors, including our infrastructures. Also, I think we also see in SDG number 9, actually, yeah, it's about industry, innovation, and infrastructure, mentioned about the need to achieve that kind of goal. So I think based on this, the question is how we can achieve that. Actually, ISC, or American Society of Civil Engineers, already have what's called the standard practice for sustainable infrastructure. This document mentioned about the leadership that we should have, yeah, in terms of how to achieve sustainable infrastructure. So we have to encourage transformation, active development of the infrastructure solution from the early stage. What we talk about this right now, I think about design. I think this is the early stage. Okay, so this is important. So not only that, I think we should also consider all reasonable alternatives, including no construction. So it's a do nothing, okay? And then maybe several constructed project solution, okay? And also, we have to also include what's called the life cycle cost analysis in this term. But this document focus also emphasize that we have to also not only building the project right, but also building the right project at the first time. So this is very important because we talk about what's called the value of the project. We should have a definition of the value of the project, and then we can deliver that kind of value during the project and with in lean construction nomenclature without wasting many resources. Okay. So this is the sustainable construction framework from CIB. I think it's a long time ago developed, I think, as a way, a platform to deliver the sustainable infrastructure. So all of the life cycle phases of the project, we should consider all the resources, and we should apply what's called the sustainable construction principle: reduce, reuse, recycle, protect nature, eliminate toxic, life cycle costing, and also still focus on the quality. The context of Indonesia, this chart, I think it's already like a year ago, yeah, produced by our National Agency for Disaster, yeah. We have a lot of natural disaster and also climate change, yeah, impacted our community all over Indonesia, yeah. So like earthquake, volcanic eruptions just recently, just yesterday, I think, and flooded, extreme climate change, yeah, and also the burn of the forest, yeah, also landslide and so on. So this can picture us that Indonesia not only focusing on the sustainability in long term, but I think we still face many problems in the way to achieve that sustainability. Therefore, we cannot only focus on the long-term goal, but we also have to focus on what's called the resiliency of our infrastructure. Yeah, because of this natural disaster. This is the impact of disasters, yeah, natural disaster. The investment of our infrastructures is gone, yeah, because of this disaster, and we cannot achieve the sustainability yet because of this. So I think we need to focus also not only the sustainability, but also how to achieve the proper and also robust infrastructure. Okay. So this is the concept of resilient infrastructure. As you can see from this picture, resiliency triangle. I think this is the important thing. If we construct the infrastructure, for instance, with the 100% of serviceability or functionality, one day at the TO, it will reduce like maybe 75% because of disaster. And because of that, we have to go back to the first stage, the initial stage, which is the very functional infrastructure. And the triangle, the smaller triangle, I think that means more resilience of the infrastructure. Okay, so also we have also to see this principle for resilient infrastructure from UNDRR and also from Sendai framework, that we not only focus on the sustainability, which is environmental and social, but also we have to make our infrastructure more resilient. Yeah. Okay, there are several time discussion about what is different between sustainability and resiliency, whether resiliency is part of sustainability or this is different, distinct. Yeah, actually there is a paradigm shift. I think starting in 2014, we discussed about different approach for sustainable infrastructure and resilient infrastructure. But in 2016, I think we try to maybe see the overlapping between the sustainable infrastructure criteria and the resilient infrastructure. However, at the maybe 2019, we conclude, we agree that resilience infrastructure should be the first step toward the sustainable infrastructure. So in Indonesia, we try to adopt this paradigm. Yeah, this is the connection between the sustainability and the resiliency. If we cannot get what's called the resilient infrastructure, because the disaster is coming and coming, over and over again, I think we cannot achieve the sustainability in the long term. That's why we should have what's called the resilient infrastructure. We can have a good infrastructure after the construction, and then maybe reduce the serviceability, but we can go back and then we try again. If there is another disaster, we can go back again, something like that. So I think this is the connection between this resiliency and sustainability. So in Indonesia, the government issue several policies, for instance, from the presidential decree regarding the master plan for disaster management, and also regarding the implementation of SDG, to achieve the SDG, mentioned about the importance of the resilience infrastructure. Actually, for the construction itself, there is a ministerial decree, from the Public Works Ministry, guiding about how to implement the sustainable construction, and it mentioned about the introduction of lean construction as the way to achieve that sustainable construction. So, ladies and gentlemen, we now go to the lean construction. I would like to explain what is lean construction. Actually, lean construction developed since 1992 by gentleman here, Lowly Koskela, on the right side. At the time, he joined with Glenn Ballard and Greg Howell to establish also called Lean Construction Institute in 1997. the definition of lean construction right now, lean construction is a project delivery process that uses lean methods. So lean methods is to differentiate between the lean construction and other method of construction of maximizing stakeholder value while reducing waste by emphasizing collaboration between teams on a project. So we can see that keywords here, value, waste, and collaboration between the team project. So the goal of the lean construction is to increase productivity, of course, profits, and innovation in industry. What is the need of the lean construction? In 1992, there was a study by Glenn Barrett. At the time, he went to the job site, to the contractors, and asking whether the tools in managing project are the okay or not, at that time. And everybody mentioned that it's okay, it's already there, already established, a long time ago. So they really use that tools, But when the Glenn Barrett asking about how many plans that are completed in a week, the number coming is 54%. It's always like tossing money, and it is like 50-50%. So I think this is the problem of the construction. And also at that time, in Construction Institute found that most of the time we only manage the project, but forgetting about how to produce the product. So I think because of that, maybe project management tools is okay, but I think we miss what's so-called the production management. Okay, if we compare between the manufacturing industry and construction industry, we can see that the performance of manufacturing is way better than the construction industry. In terms of value-added activity, in construction only 10%, while manufacturing can achieve 62%. While regarding the waste, construction, I think 57% of the activity categorized as waste, while in the manufacture only 26%. Therefore, we need to learn from the manufacturing industry. That's why the gentleman learn about the lean production from the Toyota production system and try to implement it in construction using the terminology of lean construction. Okay, so if we compare between the manufacturing and also the construction, why manufacturing can be better, way better than the construction industry in terms of performance? Because of this, if we take a look at this life cycle of the product between the manufacturing industry and also construction industry, I think the same, we have the same phase, but if we take a look at this, they are integrated. Manufacturing industry is very integrated and conducted by only single entity. That is the key why their performance is very good. Okay, while in construction, we have a very different, separated and segmented phase, along the life cycle of our products, and also done by several entities, many entities. So we have a challenge how to collaborate, and collaborate is difficult. It's not about only technology. We have talked about technology, already, just recently by two keynote speakers. Yes, they are helpful. They are supporting the managing the process, but still, many of them are done by people. Okay, so it's hard to manage the people, and it's hard to collaborate the people. That's why we need to have a method, a way how we can collaborate, make them more integrated. So I think the lean production knowledge from the manufacturing industry, I think can be helpful from for our construction industry. But still, we have to change a little bit of the knowledge and practices from the manufacturing, because the characteristic of the manufacturing and construction is different. That's why we came with our own terminology, lean construction. Moreover, many of us, only focus on the what's called the meso level. We have hierarchy, micro, meso, and macro. So in terms of managing the project, is in the meso level. And what we forget about is the operation management. The project management is unique product. Yes, of course. Yeah. But in operation management, it's not unique product. It's a cyclic or many similar component of the product. That's why the practice and the knowledge of manufacturing industry can be applied in this direction, in this hierarchy. Okay, so in terms of how we can use that information, that practice, and also knowledge, we have to adapt the manufacturing knowledge. For instance, the lean thinking principle from James Womack. It mentioned about 5 principles of lean thinking. First is we have to specify value, identify value stream, make values creating step flow, and then customer pull, and also perfection. These are the lean thinking principle. And we talk about the value, we talk about the value. We have to make it specified, not only identified. So it means that it's not only like what we want in terms of our wish or our dream, but we have to make it more quantitable. We can quantify, so we can measure it. Okay. Also, as Laurico Scala mentioned, in terms of production, we have to change our paradigm in terms of production. Usually, we see the production only like a conversion from input to output physically. Okay, he called it the transformation mindset. But we have also to integrate also the value mindset, that the result of the conversion should achieve the value of the customer. And then the third one, which is F, is flow. During the conducting to achieve the value and the conversion, we have to reduce the waste, make it the process flowing. Okay, so this is the important key of the adoption from the manufacturing to construction industry. Since 1992, there are many new knowledge practices, methods, developed by lean construction community. So if we try to map it, it's like too many things. Okay, actually, right now they try to categorize all the knowledge, into philosophy, principles, methods, and tools. And the important thing, of course, the philosophy. So there are only 3 philosophy of lean construction. First is respect for people, and then maximize value while minimizing waste. And also the last one is continuous improvement. And LCI already also established what's called the focus area of lean construction. The first one is operating system. It's related to methods, how to deliver, and then the organization regarding the human resources, and also how to do the commercial between the parties. We call it integrated project delivery. I think Dr. Lee mentioned about this, on his conclusion. So these are the popular methods, during the design phase and also construction phase. Maybe some of you don't know yet, about this. I think this is relatively new. So therefore, I would like to invite all of the participants try to learn about this, because this is what we need to master in terms of how to deliver what the value we need without causing many waste. In design, we call it set-based design, not only point-based design. So we have to try to make many solutions and try to develop the solution. Of course, BIM can help can be helpful, yeah, for this, yeah. So we can make many solution, and then based on that solution, we can try to reduce the solution into one. Okay. The last planner system is how we can collaborate between the parties of the design team, like the architect, civil engineering, and also mechanical engineering, and so on. Yeah. So by doing this last planner, I think we can try to make the planning of the design more reliable. Okay. Choosing by advantages is how we make decision collaboratively. Okay. Scrum also, the way we do the project design in terms of chunk, a very small chunk, yeah. So we can do it more rapid, and also reliable promise, how to make the promise from the every parties of the design team can be achieved, yeah. During the construction also, we have the same methods like the last planner. The new one is task planning, adopting from German, yeah, methodology. I think how we can deliver, for instance, one story each week, for instance. Yeah, every week we can deliver one story, for instance. 5S also from the Japan tradition, visual management. Also, the last one is project production management. And also, not only the operation system, the lean construction also introduce what's called the collaborative project delivery. Compared to traditional design bid build process, yeah, we have what's called IPD, integrated project delivery, and then progressive design build, and also target value delivery. Most of the project delivery should come from the owner side, and also owner roles are very important in this thing. Yeah, if we compare between the previous project delivery, for example, design bid build, EPC, or PPP, yeah, on those methods, the role of owners very limited. Yeah, owners only give the risk to the contractors or the developers or to the design builders. Yeah, but in this collaborative project delivery in lean construction, owners should take a significant role in terms of getting all the participants, yeah, coming in the beginning of the project, starting in the beginning of the project, and do the project, develop the project together. So it is not only the project of the contractors, but it's a project of the whole team. Yeah. Also, owners should also do the co-location or make a big room for everybody to go to that location and working collaboratively. Yeah, not let's separate or in a silo. Yeah. So I think right now the community, lean construction community is around the world. There are 29 communities in 29 countries. Indonesia is one of them. Therefore, I would like to invite Pak Samsul Hadi, Malaysia. Maybe I can try to join also. We have to learn something new, yeah, together, yeah. Because I think we believe, yeah, this is a good thing, yeah, that can transform our construction industry in around the world. And in Indonesia, this is the lean journey of Indonesia, starting in 2000, actually, yeah. I start to introduce lean construction at that time, but in terms of the feedback or maybe the response here from industry, it's very limited at that time. This graph, I think, related to the 196 article published by Indonesian authors, yeah, related to lean construction. As you can see, first 10 years, very limited. The second also, I think, very limited. But the last 5 years is growing up. Okay, because why? Because everybody knows that this is what we need. Yeah. At that time, I think starting in 2025, I start to work with the Ministry of Public Works to establish the ministry decree related to sustainable construction and introduce the lean construction. since then, I think everybody want to know what is lean construction. Okay, but I think since maybe COVID, because of COVID, everybody want to learn something new because they cannot do on site. Yeah, so I think they learn something, and then after that, number of articles published by Indonesian authors, I think is growing. Therefore, in last year, we established what's called the Indonesian Professional Association for Lean Construction Management. Yeah, and I am the chairman of that. So I would like to invite now, in terms of related to IGLC papers, sustainability research, I think already also mentioned and also done the research regarding that. Since 2002, related to sustainability, I think there are 113 papers, and regarding resiliency, I think about 8 papers. So I think Lean Construction in that institute also try to adopt the terminology in terms of why Lean Construction can deliver sustainable infrastructure. This is the principle, because one of the philosophy of the Lean Construction is maximizing value, but minimizing waste. The problem is, what is the value? So I think the sustainability is the value. At that time, there are discussion, whose value? Is it only the value of the one who pay, or maybe more than that? Maybe wider than that. And maybe we can also try to include not only the paying customer, but also the society, also maybe right now the nature. And therefore, I think we can conclude right now the value coming to sustainability, not only the paying customer. So in terms of sustainability, this is the number of papers in IGLC. I think there's a trend also, as you can see, in construction, sustainability is increasingly being recognized, not just an intermediate value, but as final value. This is a good indication. So I think sustainability going to be like the value that should be achieved. And then also in terms of resiliency, Lean Construction method play a crucial role in supporting resiliency, especially in dynamic and high-risk environment like in Indonesia. Maybe not in Malaysia. I don't know about that. Maybe we can discuss about that. So, in summary, ladies and gentlemen, for Indonesia context, Lean Construction is the way construction industry should operate in order to achieve resilient infrastructure as the pathway toward sustainable infrastructure. So for that, I conclude. Thank you very much. So if you want to know more about me and other activity related to the Lean Construction, you just scan the QR code. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Muhammad Abduh. Very engaging keynote presentation, I would say. We have hear from 3 distinguished keynote speakers on the topic, commencing from Professor Survey Dr. Karunita Ali on BIM and how are we going to integrate BIM with 5D BIM, if not mistaken. And then our second keynote speaker, Dr. Lim Yewah, he presented on the future of BIM for sustainable infrastructure or development. And our final keynote speaker, Prof. Muhammad Abduh, has already presented to us or reignite, I would say, our interest on lean construction. And what can I say from the keynote paper presented by Prof. Abduh is that he has already highlighted on how lean construction principle especially can transform the way we plan and also deliver infrastructure, thereby reducing waste, optimizing resources, and driving long-term sustainability. And I think most interestingly, the point highlighted by Prof. Muhammad Abduh on sustainable resilient infrastructure, especially in disaster-prone area, is a move in the right direction. And thank you again, Prof. Muhammad Abdul, for the excellent keynote. We have a question from the audience, but unfortunately, I think we can't read the question now because of the time. We are almost running off the time that we allocated. And with the excellent presentation from all our keynote speakers, and we are now coming for a short break. Before we pause for the conference for the short break, I would like to invite everyone for a quick photo session, perhaps. And for that reason, I would like to request all attendees to turn on their cameras for the virtual photo session. Can we all turn on our cameras so we can have a quick photo session? I think the technical committee will be handling the process. Okay.
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 First page. Smile. Keep on smiling.
Yep. They have 4 pages, I think.
Wait.
Someone is
Someone is sharing.
sharing the screen. All right. Okay.
Not yet. Wait.
Not yet. Okay. Again, Dr. Shikin. Yep.
Okay.
Yeah.
Stand by.
Okay, I'm doing a group photo session, so everyone please allow the camera to take your photos so I can get a more high quality photo lah.
Okay.
Okay, thank you, Didi.
Thanks, G.
Are we done smiling? Not yet.
Okay.
Is it done, Dr. Faiz?
Yes.
I see. Okay. Thank you so much. Thank you again for your cooperation. And now we'll be taking a short 6-minute breaks. Unfortunately, we plan to have 10-minute breaks, but unfortunately, we are running out of time by 4 minutes. So we are going to take about a 6-minute break. Right after the break, we will continue with the oral presentation of the technical papers. The conference will reconvene later around 10:50 a.m. I repeat, 10:50 a.m. So I hope you can enjoy your break, and we'll see you right again after the break. Thank you so much. Okay, while you're having your break, just a short announcement for our next event. So we'll be having BIM RG Tech Week CPD event. This is an online webinar, and the theme that we have already set for this online webinar is transforming QS and construction stakeholders' role with BIM in CDM regulation. So if you happen to wishing to expand your knowledge on the application of BIM in CDM regulation, feel free to register for this CPD event. So it's only RM50 per person, and the details on how you will be able to make the payment is currently displayed on the screen. So the CPD event is going to take place on 28 November, next Friday. So it's going to run half day from 8:30 a.m. to 12:30 p.m. And the good news is we have 2 CPD, BQSM CPD points approved. So those from the QS background, so if you are currently short of 2 BQSM CPD points to renew your membership renewal next year, so this perhaps the last chance for you to add up to your CPD points. Thank you so much. So we are looking forward for your registration and also participation in our next CPD event. Thank you so much.
In BIM Research Group, our focus is on advancing digital construction and smart project delivery through the application and development of BIM technologies. Over the years, we have forged strategic partnerships with select organizations from both academia and industry, fostering collaborations that contribute meaningfully to society. We undertook research and development initiatives in alignment with the university's aspiration to become a leading reference center for science and technology applications. As a research group, we welcome any forms of collaboration by members of the public, company, or organizations. We are actively looking forward to forge new partnership and avenues which we can lend our knowledge and ideas for the improvement of the society. Just last year, we launched our tagline, Beyond BIM. It reflects our vision to lead digital transformation in the built environment through innovation, education, and industry collaboration. We hope with your continuous support, we would be able to reshape the construction by moving past traditional BIM application into new frontiers of knowledge and practice. Come and talk to us, drop us an email, and we'll see how we could work together. Beyond BIM, from the BIM Research Group, University Technology Malaysia.
Assalamualaikum and a very good morning to all distinguished guests, speakers, and participants. Again, we continue with our next session on the oral presentation. Before that, I also would like to again welcome you to the 2025 Second International Conference on Environment Engineering, Urban Planning and Design. Our theme this year is on Accelerate Sustainability through BIM and Digital Innovation, reflecting our collective pursuit of smarter, greener, and more resilient cities. My name is Hamizah Liana, and I am honored to serve you as your moderator for today's oral presentation session. I would like to kindly remind to all the presenters that you will be given around 10 minutes for your presentation, which will be followed by Q&A session. And please note that the timing will be displayed on the screen, and we may need to gently interrupt you if the time is exceed to ensure that the program is run smoothly. Thank you for your cooperation in keeping the time for the session to follow as per schedule. We will now begin our presentation. It is my pleasure to invite our first speaker, Mr. Jun Zeng from Chongqing Vocational Institute of Engineering, China. And Mr. Jun Zeng will be presenting his work entitled Research on Expressway Service Area Spacing in Mountainous Chongqing. Mr. Jun Zeng, you may now share your screen and begin your presentation. Thank you.
Okay, thank you. Can you hear me and see my PPT?
Yes.
Okay. Good morning, respected experts and scholars. My name is Jun Zeng from Chongqing Vocational Institute of Engineering. Today, I'm very glad to show you my research on expressway service area spacing in mountainous Chongqing. This study focuses on how to scientifically determine the spacing of service areas in Chongqing's mountainous expressway network. So, service areas and parking areas are essential facilities for expressway systems that provide fuel maintenance, rest, and safety support for drivers and passengers. However, in China, many highways still use fixed spacing standards. For example, one service area every 50 kilometers and one parking area every 25 kilometers. While this works in flat regions, it often fails in mountainous areas like Chongqing, where steep slopes, sharp curves, and long tunnels make driving much more demanding. As a result, some sections have too few facilities, leading to safety risks, while others are too dense, wasting resources. This imbalance is what motivated our research. So our main objectives are threefold. First, to analyze the key factors affecting service area spacing in mountainous regions. Second, to develop adaptive spacing strategies suited to Chongqing's unique terrain and traffic patterns. And third, to provide a scientific reference for future expressway service planning in Western China and other mountainous regions. This research aims to bridge the gap between engineering standards and real-world geographical conditions. We used a mixed method approach to combining both quantitative and qualitative analysis. Simulation tools such as AnyLogic, PKPM Energy, and MITNIB were used to test different spacing layouts and energy demands. Finally, we conducted field surveys and driver interviews to understand real user needs and fatigue behaviors. We identified 7 main factors influencing service area spacing: drivers' physiological and psychological needs, manual rest, and fatigue prevention, fueling, water and maintenance requirements, traffic volume and vehicle composition, environmental protection and cultural integration, construction and operational economics, land use efficiency, topographical and geological constraints. Among these, driver fatigue and terrain conditions proved to be the 2 most critical determinants in mountainous areas. Let's take a look at the situation in Chongqing. Field surveys show that the distance between some service areas exceeds 70 kilometers, such as on the Nanhai Expressway. This is far beyond the recommended safe interval and forces heavy trucks to stop illegally along the roadside for rest or auto refill. On the other hand, some low-traffic corridors have service areas located too closely, leading to low utilization and repeated investment. So in summary, the one-size-fits-all model simply doesn't work here in Chongqing. So internationally, we found that in Europe and the US, rest areas are spaced about 5 to 25 kilometers apart, while full service areas are around 20 to 30 kilometers. Japan keeps a standard of 30 to 60 kilometers, combining service and parking functions efficiently. In China, most provinces use 30 to 60 kilometers for service areas, but adjust spacing based on geography. These comparisons show a clear trend. Developed regions tend to use shorter and denser spacing, ensuring frequent rest and safety stops. However, Chongqing's mountainous terrain and higher construction cost mean we need selective adaptation, not blind imitation. So based on our analysis, we propose 4 adaptive strategies. Regular sections, spacing of 30 to 50 kilometers for standard terrain. High-risk sections, reducing spacing to about 15 kilometers with added water and cooling facilities for heavy trucks. Terrain constrained sections, adopt flexible layouts such as linear, shared, or multi-level service areas to save land. Flight or resource-rich sections, build dual-site, fully functional service areas with potential for commercial expansion. In practice, we commanded a main service area plus auxiliary parking area plus small rest node system. This multi-level structure ensures that every 15 to 20 minutes of driving, a driver can find at least one form of service facility. Planning should follow the principles of no land acquisition, no energy use, and high flexibility. Also, future layouts must reserve interfaces for renewable energy systems, such as EV charging station and hydrogen fueling and smart grid access. Let me summarize our key findings. The traditional fixed interval model is not suitable for Chongqing's mountainous expressways. So multi-factor integrated model combining traffic, terrain, human, and economic factors is essential. Zone differentiation and flexible spacing are the most effective planning strategies. Existing practices in Chongqing, such as Rulong and Tongliang service areas, show good progress but still need optimization. Future service areas must consider scalability, digital management, and new energy integration to meet sustainable development goals. This research provides both theoretical and practical guidance for mountainous expressway planning in Western China. So thank you very much for your attention. Thank you.
Thank you, Mr. Zheng, for a very insightful and informative presentation. I open to any questions from the audience, if any. Or maybe you can put it in the chat as well. So before we end the oral presentation session, maybe can read the question later. Moving on, I would like to invite our second presenter for today, Mr. Rui Ji Liu from the University of St. Joseph, Macau, China, with his research entitled From Algorithmic Intent to Accountable Assembly, a Computational Delivery Framework for Digital Architecture. Mr. Rui Ji Liu, the floor is yours. You can start to share your presentation.
Thank you. And let me share my screen. Okay. Can you see my screen?
Yes, I can.
Okay, this hello everyone. Thank you for attending today's presentation. My name is Rijie Liu, and I'm excited to share with you my research on digital architecture and computational workflows. Today's talk will cover the framework I propose, which is aimed at bridging the gap between parametric design and real-world delivery in architecture. And we will explore how computational systems can be used to design buildings that are not only innovative, but also practical and accountable to real-world constraints. Over the last few decades, parametric design has radically changed how architects approach form making. No longer driven solely by intuition, design is now orchestrated by algorithms and generative systems. These systems take into account structural, environmental, and spatial considerations. But despite the advancements in computational design, there remains a significant gap between the creative exploration of form and the actual construction of buildings. In practice, regulatory material and life cycle constraints often limit the full realization of these designs. To address these challenges, I propose a framework called the Computational Delivery Framework, which is the CDF in brief. The CDF helps trace the journey of design intent from conceptualization to fabrication and performance validation, ensuring that innovative designs can be successfully implemented in the real world. Today's talk will cover the following areas. First is the parametric design logics, how computational systems encode design intent. Then fabrication workflows, how designs are materialized through different manufacturing techniques. And the third one is the validating design intent, how we ensure that designs meet real-world performance and regulatory standards. After that, I will give a conclusion and the future direction. So let's go to the first part. One of the key concepts in parametric design is form finding. This approach is rooted in the idea that form is not something fixed or predetermined. Instead, it is the result of forces, material interactions, and environmental conditions. Think about the early experiments of architect Fry Otto, where he used the materials like hanging chains or soap fumes to explore structural efficiency. These forms were generated by natural forces like gravity, which helped identify efficient minimum surfaces. Today, we replicate these ideas digitally using tools like Kangaroo in Grasshopper to simulate real-time force-driven geometries. A good example of this in action is the Barcelona Pavilion, where the form of the structure was influenced by the natural behavior of materials and the structural forces. In computational design, we are often faced with multiple conflicting objectives that need to be balanced. This is where multi-objective optimization, MOO, comes into play. MOO helps us navigate these competing goals. For example, when designing a building facade, we might want to balance daylight access with thermal performance. MOO uses evolutionary algorithms to explore various design solutions that achieve the best balance between these objectives. Tools like Octopus and Wallace in Grasshopper allow us to perform this type of optimization, generating a range of solutions that can be evaluated and compared to identify the best one. The third key element in parametric design is the human-computer coagency. This concept challenges the idea that design is solely human-driven or computer-driven. Instead, it's a partnership. In this model, the computer helps generate design options, but it is up to the human designer to make the final decisions, curating the output based on the specific context of project needs. Tools like interactive evolutionary algorithm allow designers to set parameters and guide the system towards solutions that reflect their judgment and qualitative criteria such as aesthetic appeal or user experience. And then let's go to the fabrication workflow. The first manufacturing workflow we will discuss is subtractive manufacturing using CNC technology. This process works by removing material from a solid block, typically using tools such as mills, routers, or lasers. It's well suited for creating highly accurate parts, especially for large-scale production. One of the major strengths of subtractive manufacturing is the precision. A CNC machine can create extremely accurate geometries and are commonly used for producing both large components and high precision parts. But this method has some limitations. The main one is the waste production. Because material is removed rather than added, a significant amount of waste can be generated. Additionally, certain complex geometries like internal cavities or intricate curves can be challenging to produce. Now let's move to additive manufacturing or 3D printing. Unlike subtractive methods, 3D printing adds material layer by layer to form the final object. The primary advantages of 3D printing is its ability to create complex geometries that would be nearly impossible or prohibitively expensive to produce using traditional methods. This is particularly useful in industries where custom or small batch parts are needed. Another benefit is that 3D printing generates much less waste compared to subtractive methods, as materials only added where needed. It's an ideal solution for rapid prototyping and for producing one-of-a-kind parts. But it's not without its challenges. One issue is the material properties. 3D printed parts often exhibit anisotropy, meaning they are stronger along certain axes but weaker along others. Additionally, while it's great for prototyping and small batches, 3D printing is generally slower than traditional methods, making it less efficient for large-scale manufacturing. And then let's go to the validating design intent. In this part, we address the systematic barriers that prevent computational designs from transitioning to full-scale architectural projects. These barriers are not merely technical limitations, but also involve economic, regulatory, and cultural obstacles. On the economic side, high initial costs, fragmented supply chains for non-standard components, and the difficulty of scaling these technologies are key challenges. Another major barrier is the lack of established regulations for new fabrication methods. Without clear building codes or certification pathways, digital designs may struggle to obtain necessary approvals or insurance, even if they perform well in prototypes. The final challenge lies in the cultural resistance from the construction industry. Many professionals are still reluctant to adopt these new technologies due to skill gaps and the fear of change. Overcoming this resistance is crucial to scaling digital fabrication methods. One of the most effective ways to validate digital design intent is through envelope systems, specifically facades and roofs. These systems serve as test beds where performance can be directly measured. Okay, let's go to the conclusion and the part. As we wrap up this presentation, let's review the key takeaways and look ahead to the future digital architecture. First, I've introduced the computational delivery framework, CDF. These three-phase models maps the entire journey of design intent from conceptualization to fabrication and validation. It ensures that computational designs are not only novel, but also viable in the real world. Secondly, we have seen how facades and roofs act as strategic test beds for validating digital designs. These systems provide a practical way to assess energy efficiency, regulatory compliance, and long-term durability. Finally, I have proposed a shift towards performance-accountable innovation. In the future, generative designs must not only be innovative, but also certifiable, insurable, and maintainable across their life cycle. Here are some future directions. And in conclusion, the future digital architecture lies in balancing generative complexity with practical accountability. Through better integration of performance metrics, regulatory compliance, and the lifecycle management, we can achieve truly sustainable, resilient buildings that are capable of meeting both innovation and real-world demands. Okay, thank you. This is my presentation.
Okay, thank you, Mr. Liu. From your presentation, I can see that you provide a very fresh perspective in terms of digital architecture and on its practical implementation. And I believe that your framework also provide a strong potential to improve and to provide a good innovation in terms of architectural delivery. Is there any questions from the floor? If there's no question, I might have one question for you, Mr. Yuji. Just now you mentioned about some barriers in terms of implementing this framework. How do you think that these barriers can be handled by the industry? Among others, in terms of refuse to change or adopt digital innovation.
Okay, thank you for the question. Yes, we suffer from some barriers. And for example, by using the framework I proposed, we will produce. We will have some plans beforehand, and we will also deal with the negative aspects of different construction methods, for example, the subtractive ones, the additive ones. Instead, we will use the robotic construction and the robotic construction has I think it integrates the advantages of both subjective and additive manufacturing methods, but the invest at the first step is relatively high, but we will combine different methods using robotic construction, and at the same time, if needed, we will complement this method with subtractive and additive methods, and I think this should be we should have a well-planned schedule beforehand. Thank you. This is the answer from my side.
Okay, thank you so much for your response. Okay, moving on to our third presenter. Before that, we should give a round of applause to Mr. Reggie Liu for his very nice and engaging presentation. Moving on to our third speaker, we have Mr. Kai Hu from Hebei University of Engineering, China, which he will be presenting his research entitled Cadmium Isotope Fractionation Constraints, Multi-Model Quantitative Source, Apportionment of CD in Farmlands Affected by Coal Mining. Let us welcome Mr. Kai Hu. Mr. Kai Hu, you can start to share your slides and begin your presentation. Thank you.
Yeah, I share my screen. Okay. Good morning, Mr. Chairman, ladies and gentlemen. I'm Hu Kai from Hebei University of Engineering. It's a great honor to present our research at Eeupd 2025. The topic of my presentation is cadmium isotope fractionation constraint multimodal quantitative source appointment of CD in farmland affected by coal mining. This work was conducted under the supervision of Professor Wang Li Shu. My presentation consists of 4 parts. First, the background and scientific issues. Second, our research idea and the methodology. Third, the core research content focus on source appointments. And finally, the summary and the conclusions. Yeah, so let's begin the background. Heavy metal pollution in farmlands is a major threat to global food security. Among those metals, cadmium is our primary concern because it accumulates repeatedly in edible plants and pose severe toxicity to humans. Our study focuses on the agro ecosystems in minerals, as shown in the global distribution map, where different regions face different pollution challenges. Cadmium is a priority pollutant in our study area. Okay, the key scientific questions we aim to answer: where does the CD come from in these mean agricultural interaction rooms? Is it from industrial dust, corn gang, or farming activities? And importantly, which exposure pathway contributes the most to health risks? To answer this question, we develop developed a rigorous technical route and member identification multi-model source analysis, source specific risk assessments. Traditional methods of struggle to distinguish overlapping pollution source. Therefore, we integrated stable CDS topics with statistic model like PCA and PMF. Specifically, we utilized the Mixel model based topics missing models to quantify source contribution with higher precision. We conducted multi-medium sampling, including TSP, soils, irrigation water, and crops to construct a reliable and member library. So, moving on to the research content. We first analyzed the source migration exposure mechanism. We identified the main input, industrial dust, including coal gas, transportation, and agricultural inputs. Our source profile analyzed 0 to 80 cm relevant the significant CD accumulation in the closed layer. This vertical distribution pattern strong suggest anthropogenetic impulse rather than geological background. So correlation analysis further confirmed that CD behaviors differently from other materials, indication unique mean driver source profiles. So this is the most critical part of our finding, quantitative source appointment. By combining CD topics tracing with PMF and Mixel model, we achieved precise quantification. Please look at this chart. The results are consistent across models. Industrial activities related to mining and smelting are the dominator source, contributing between 49.5% and 52%. The atmospheric deposition is the second largest contributor, accounting for 36.1% to 38%. Traffic source contribute approximately 9.5% to 10%. This data confirms that industrial emission and atmospheric deposition are the absolute primary driver of CD pollution in this region. Comparing the mean zone with the control L, the mean zone show a significant higher intensity of industrial contribution. So, based on this source, we conducted a source-specific health risk assessments. The results are alarming for non-risk. The hero quintin for children is 3.8, far exceeding the safe threshold of 1. For adults, it's 1.2. For risk, the value is 2.1, which is also above above the acceptable limit. Our analysis identified that the dietary intake pathway, specifically the consumption of locally grown crops like wheat, is a primary exposure route. This highlights the urgent need to cut off the transfer of CD from industrial dust to the soil crop systems. So to summarize our study, we successfully established a concentration statistical isotopes risk framework. This framework effectively resolves the complex choice in mean agricultural interaction zones. We confirmed that industrial activities and atmosphere depollution are the dual primary source of pollution. So we provide the theoretic basis for zone soil control, mitigation strategies must focus on suppressing industrial dust and managing corn gain to protect food safety. This workflow is reproducible and can be applied to similar regions globally. So that concludes my presentation. I would like to thank you, Eeupd and Hebei University of Engineering for the support. Thank you for your attention. Yeah.
Okay, thank you so much, Mr. Kai Hu
Yeah.
from Hebei University. It is a very informative presentation. But since I am from quantity surveying background, this research I'm not very that familiar with this kind of topic, but I believe it has a lot of very informative information that could impact in terms of sustainability and maybe reduce the issue on pollution, I suppose, okay, and give a good impact towards the environment. Do we have any questions from the floor for Mr. Kai Hu on his presentation? Anyone? Maybe you can impose the questions in the chat box later also. Okay, Mr. Kai Hu, thank you for your presentation. Moving on to our next presenter, we have a bit of a change towards the presenter. Our next presenter will be Miss Hairun Amira Hishamuddin from University Technology Malaysia, entitled Rethinking Liabilities and Responsibilities Towards a Balanced Resharing Framework in Building Information Modeling. I would like to invite Ms. Hairun Amira to share your presentation. Meanwhile, I can see Mr. Hukai, there are one questions in the chat box. Maybe you can reply to the question as well in the chat box. Thank you. Okay, Mr. Harun, the floor is yours.
Can you hear me? Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. My name is Hayun Amira from University Technology Malaysia. My presentation is based on the paper titled Rethinking Liabilities and Responsibilities Towards a Balanced Risk Sharing Framework in BIM. In this presentation, I will explain why risk sharing is an important issue in BIM-based construction projects, what are the current problems are, and why future research on equitable risk sharing is urgently needed. As an introduction, Building Information Modeling, or BIM, has changed the way we manage construction projects. It allows all project members to work on a shared digital model, communicate in real time, and reduce many traditional coordination problems. But even though BIM makes collaboration easier, it also brings a new set of challenges. Because everyone works on a shared model, it becomes unclear who is responsible when something goes wrong. Traditional contracts were not designed for this kind of digital teamwork. Most contracts still treat BIM as just an add-on instead of a main project requirement. This creates confusion, legal uncertainty, and sometimes conflicts. So the goal of this paper is to highlight the need for a fair and balanced risk-sharing framework, which is a model that can help stakeholders work together more effectively in BIM-based projects. When roles and responsibilities are unclear, people start to feel unsafe. They worry about blame, legal exposure, and financial losses. This leads to defensive behavior, less cooperation, and sometimes disputes. But in BIM projects, everyone is connected. If one person makes a mistake, it affects the whole team. That is why equitable risk sharing is important. This paper argues that to make BIM work smoothly, we need a clear and fair way to distribute risk among all stakeholders. This study is shaped around 3 key research questions, and they are all connected. First question, what are the stakeholders' perception of equitable risk sharing in BIM-based projects? Before proposing any model, we must understand how people feel. For example, do they think the current system is fair, or do they trust BIM process? This perception influences behavior. If people feel something is unfair, they will not fully participate. For second question, what are the essential attributes of equitable risk sharing and cooperative behavior? Once we know the perceptions, the next step is to identify clear characteristics of fairness. These include things like transparency, responsibility, clarity, trust, and shared accountability. These attributes help to build practical frameworks, not just theory. And the last question, what is the relationship between equitable risk sharing and stakeholder cooperation? This is the most important question. We want to know if risks are shared fairly, does cooperation actually improve? Or does project performance improve? Connecting these questions allow future researchers to design a strong and evidence-based model. For this part, I will summarize. Right now, many contracts do not support BIM properly. Some key issues include the BIM model is not legally recognized. Many contracts still rely on paper documents, so when something goes wrong in the BIM model, no one is sure who is responsible. BIM rules and responsibility are unclear. For example, the information manager role is often certainly defined. There's also different standards are used in different projects. Without standardization, disputes easily occur, and most standard contracts are outdated. Contracts like FIDIC, PAM were never designed for BIM. Even when BIM protocols are attached, they often do not have legal strength. Because of these barriers, stakeholders end up guessing responsibilities or shifting blame, which leads to conflict rather than collaboration. Previous research identifies major categories of BIM-related risks. First, BIM and contractual risks, which include unclear ownership, unclear IPR, and uncertain liabilities. Contractual technological risks, data-related risks, for example, data loss, manipulation, organizational risks like poor leadership, unclear rules, or resistant to digital change, financial risks, where BIM requires hardware, software, and training, and these costs can be high. These risks are interconnected. A technological failure can cause financial loss. A legal uncertainty can create tension. So BIM risk management must be holistic and well balanced. This paper is actually called for the need for an equitable risk sharing model for BIM projects. Such a model should match risk with capability, support clearer rules, promote transparency, and encourage long-term collaboration. Theoretical foundation like game theory, social exchange theory, and collective action theory show that fairness strengthens cooperation. However, current BIM frameworks are not enough. Most models are fragmented, outdated, or too limited. So more empirical research is necessary to design, test, and validate a model that truly works in real BIM environment. To conclude, BIM has a great potential to improve construction collaboration, but the current legal and contractual system are not ready for its interdependent digital environment. And this paper highlights the gap and stresses the need for a balanced and equitable risk sharing framework. By understanding stakeholder perceptions, identifying fairness attributes, and testing the link between fairness and cooperation, the future research can develop a model that improves trust, collaboration, and project performance. Ultimately, the aim is to transform BIM from just a digital tool into a strong collaborative platform that supports fair, efficient, and sustainable construction delivery. I think that's all from me. Thank you.
Okay, thank you so much, Ms. Hairun Amira, for your wonderful presentation. And I can see that your discussion, which focusing on the liabilities and responsibilities of parties in the BIM environment, do highlight an important gap in the digital construction practice. And it also emphasized on creating a more balanced and transparent risk sharing framework. As we can see that our construction industry are most likely moving forward into implementing building information modeling for most of the project. I have one question for you. In terms of the issues or barriers in terms of contractual matters that you have highlighted in your presentation, who do you think have the upper hand in terms to promote the collaborative ideas in any project for that matters, or particularly in BEAM project. Because I would say that the issues with, among others that you have highlighted, like trust, is something that more or less embedded into our culture. So, what is your opinion on that?
I think, in my opinion, the person who is need to highlight this issue is the person who is participate in the project team. They need to have this kind of knowledge to know and to give their to participate to participate in the project for the successful of equitable risk sharing for the better BEAM project performance.
Okay, thank you, Ms. Harun. Is there any further questions from the floor for Ms. Harun? We welcome any questions from the audience. No? Okay, maybe there I can see, okay, one question in the chat box here. What key elements should be considered when developing a fair and balanced risk-sharing model for BEAM-based project in the future? What are some of the elements that we need to consider to develop a fair and balanced risk-sharing model? Maybe some of it. From Dr. Hazrin.
I think it's trust, communication quality, and collaborative behavior.
Okay, yeah, I believe so as well, among others. Yeah? Okay, thank you, Ms. Harun. Thank you for the questions and thank you for your answer. Thank you so much for a very nice presentation. BEAM and happening at the moment. Next, before we move on to our final presenter, I have one announcement to make. We do have a session in this evening. This afternoon at 2:30 p.m., we will be holding a side event, which is the academic symposium in conjunction with the Eeupd conference, where some of our postgraduate students will be sharing about their research. Okay, you are warmly invited to join the event, and maybe if you want to give some feedback or also to share your experience in terms of conducting research to our postgraduate students. It will begin at 2:30 p.m. today, okay? After we have our lunch break session. Okay, last but not least, I would like to invite our final presenter for today, our presentation session. We have together with us Mr. Lin Lu Zhou from Qingdao University of Technology, China, with his research entitled Thematic Analysis and Future Directions of artificial intelligence integration in physical education and sports in China. Let us welcome Mr. Lin Lu Zhou.
Oh, thanks. Thanks. Good morning, everyone. Today, my presentation is titled Experimental and Numerical Investigation on Improving the Liquefaction Resistance of Sand. First, let me introduce the research background. In recent major earthquakes, sand liquefaction has triggered numerous geotechnical failures, including large-scale ground settlement, ground fissures, and structural damage caused by foundation failure, resulting in the significant loss. Current studies on the liquefaction resistance of sand mainly rely on experimental methods such as cyclic triaxial test, shaking table test, and cyclic simple shear test. Numerical approaches primarily include finite element mass and discrete element mass. Next, I will briefly introduce our experimental investigation on improving the liquefaction resistance of reinforced sand. We conducted the cyclic triaxial test and reinforced the sand samples using sisal fibers and geotextile. The tests were performed under strain-controlled loading. We conduct this lead shows a typical liquefaction response curve under a sinusoidal shear strain input. We can observe the evolution of shear stress, excess pore pressure, shear stress strain loop, and mean effective stress over time. Here is the influence of shear strain amplitude on sand liquefaction. As the cyclic strain amplitude increase, excess pore pressure build up, accelerate. The slope of the hysteresis loops decrease more rapidly, and the effective stress drops faster. This indicates that liquefaction progresses more quickly under larger strain loading. This data shows the influence of fiber content and geotextile layering. As fiber content or the number of geotextile layer increase, the build up of excess pore pressure slows down, indicating that both reformant measures significantly enhance liquefaction resistance. Next, I will present the numerical simulation of the liquefaction and resistance test. In our numerical model, we use a fluid solid cooked Eeupd element to represent the soul. The modeling concept represents the stress state along the mix shear stress plane in the triaxial specimen. Here are the simulation results. The numerical curve agree with the experimental data, demonstrating the reliability of our modeling approach. Finally, let me summarize our findings. Both the liquefaction resistance test and numerical simulation provide valuable insights into the mechanism and improvement of sand liquefaction resistance. That concludes my presentation. Thank you.
Okay, thank you, Mr. Zhao. I think we have a bit hiccup here because the topic that we got is quite different from the one that you presented. Never mind. I would like to open to any questions from the audience in regards to this presentation.
Hello, Assalamualaikum, and good morning.
Morning.
Okay. I think I have one question. From the presentation, we agree that the sand reinforcement is very important to reduce liquefaction during the earthquake. But do you think it's applicable in real life? Because what from your data is all very data-like, and I don't know if it's applicable in real life. But if yes, what do you think is the main challenge that need to be faced for the successfulness of this sand reinforcement during to reduce the liquefaction during earthquake event? Thank you.
Oh, thanks. Thank you. I think there are some challenges in the engineering applications in the future. We will try to we will try to implement this in practical projects in the future. Thank you.
Okay, thank you, Mr. Zhao, for the reflect on the question. If there is no more further question, ladies and gentlemen, dear audience and participants, that with that final presentation, we have come to our conclusion and to the end of our oral presentation session. Let us once again thank you to all our presenters for their contribution, insights, and commitment to advancing sustainability through digital innovation. And we really hope that you have found the discussions and presentation by our today's presenter is insightful and beneficial, and maybe could be thought-provoking in terms of looking into future potential research and future contribution to provide more sustainable environment. Yeah. And now we are going into 10 minutes break before we go to our next session on award ceremony and also to the closing remarks by the chair person for this event. Okay. And also I just like to give a warm reminder on our evening events on the postgraduate presentation or postgraduate symposium incorporated in this conference. Okay, we are going to have 10 minutes break. And if there is any of you who has not yet registered or missed the registration in the morning, we will give you the QR here. You can scan for to get to do the registration. And thank you so much for your participation during this oral presentation. And with that, I leave you for a short break before we continue with the award ceremony. Stay tuned. Thank you, everyone.
Hi everyone, welcome back to our closing ceremony. So I hope everyone is having a good and amazing discussion during the presentation session and can bring back some ideas to further strengthen your research. So now we have come to the most exciting part of the conference, which is the award ceremony. So for the first award, we will start with the first award, which is the Best Paper Award. So for the first track, the winner is Zinru Yan from Hefei General Machinery Research Institute with the paper title Application of Magnetic Coagulation High Efficiency Precipitation Process in the Advanced Treatment Section of Sewage Treatment Plants. Congratulations, Zinru. Is Zinru in the session now? No? All right. So next, for the second best paper for this track, the second track, the winner is Zizhou Shen from Shenzhen University with the title Coupling Mechanisms of Sustainable Daily Vitality and Resilient Disaster Recovery in Flood-Prone High-Density Urban Areas. Congratulations. The third for the track number 3, the winner is Lo Wei from Chongqing Architectural Design Institute with the title Research on the Pre-Planning of Planning, Spatial and Calculation Integrated Development Mode of Urban Renewal Projects. Congratulations, Lu Wei. Next track number 4, the winner is Ji Wu from Suzhou University with the title Research on Protection and Renewal Strategies for Residential Historical and Cultural District from a Multi-Dimensional Synergistic Perspective, a case study of the North Street area in Pingwang Town, Suzhou. Congratulations, that's a very long title. Right, and the last track, the winner is Jundong Fu from Southeast University with the title A Study on Carbon Asset Management Models under the Global Sustainable Development Context. Okay, and next, moving on to the overall best paper, the winner is Zihao Shen from Shenzhen University. Congratulations, Zihao Shen. Next, we will have the Best Presenter Award. And the winner is Ms. Hairun Amira Hishamuddin from University Technology Malaysia with the title Rethinking Liabilities and Responsibilities Towards a Balanced Risk Sharing Framework in BEAM. Congratulations, Hairun. Congratulations to all the winners, and to those who didn't score any award, that does not mean that you're not good, okay? So keep on trying and improving. So without further ado, I would like to invite technologist Dr. Nafisa Abdurrahiman to deliver her closing remarks. As a conference general chair to deliver her closing remarks. Please welcome, Doctor.
Thank you, Dr. Naki. Can you hear me?
Yes.
Okay. Good afternoon, dear distinguished guests, speakers, presenters, participants, and colleagues. On behalf of the organizing committee and as a representative of BIM-RG, it is my honor to deliver the closing remarks for Eeupd 2025. First, I would like to express my sincere gratitude to everyone who has been part of this conference, our keynote speakers, paper presenters, reviewers, participants, invited guests, industry partners, and of course, the dedicated organizing teams. Your involvement and support have contributed significantly to the continuity and smooth execution of this event. Thank you all for your commitment and presence. Ladies and gentlemen, digital methods continue to shape the way planning, design, and environmental work evolve across the field. This direction is reflected in our theme, which is Accelerate Sustainability through BIM and Digital Innovation, which captures how technical tools and sustainability goals are becoming increasingly interconnected. Eeupd provides a platform for us to observe these shifts, exchange perspectives, and remain aligned with the current developments in the environmental engineering and urban development. I'm also encouraged by the presence of participants from diverse backgrounds. We can see just now we have international participants. And also this conference covers areas of expertise from diverse and enrich our discussion and supports the development of approaches that are practical, adaptable, and responsive to different working environments. Allow me also to acknowledge the commitment and effort for all organizing teams who have coordinated the many moving parts of this event. Their work ensured clear communication, a smooth process, and also a well-managed program from start to the end. Quite smooth for the event today. Thank you for your dedication to all of you. And to all participants, thank you once again for your time, engagement, and contributions throughout the sessions. Your presence really strengthens the exchange of ideas and support continuous advancements in this field. We truly appreciate your support for Eeupd 2025, and we wish you every success in your upcoming endeavors. With that, I formally conclude the Eeupd 2025 conference. Thank you to all of you. So before I end, just a brief announcement. So this afternoon, as mentioned by Dr. Miza just now, at 2:30 p.m., we will be holding a side event, the academic symposium in conjunction with the Eeupd conference. Our postgraduate students will be sharing insights from the research. So you are warmly invited to join the session. So thank you very much to all of you. With that, this is the end of our morning session for today. Thank you very much.
Thank you so much, Technologist Dr. Nafisa binti Abdul Rahiman. So we have now come to the end of our morning session. So on behalf of the organizer, we would like to thank each one of you for participating and see you again next time. Thank you so much and have a very good day. Thank you.
Okay, thank you. Bye.
In BIM Research Group, our focus is on advancing digital construction and smart project delivery through the application and development of BIM technologies. Over the years, we have forged strategic partnerships with select organizations from both academia and industry, fostering collaborations that can contribute meaningfully to society. We undertook research and development initiatives in alignment with the university's aspiration to become a leading reference center for science and technology applications. As a research group, we welcome any forms of collaboration by members of the public, company, or organizations. We are actively looking forward to forge new partnership and avenues which we can lend our knowledge and ideas for the improvement of the society. Just last year, we launched our tagline, Beyond BIM. It reflects our vision to lead digital transformation in the built environment through innovation, education, and industry collaboration. We hope with your continuous support, we would be able to reshape the construction by moving past traditional BIM application into new frontiers of knowledge and practice. Come and talk to us, drop us an email, and we'll see how we could work together. Beyond BIM, from the BIM Research Group, University Technology Malaysia.
Final call for our next event, BIM-RG Tax Week CPD event. This is an online webinar with a theme transforming QS and construction stakeholders' role with BIM in CDM regulation. So this is our final call for participation. So the event will take place on 28 November 2025, next week's on Friday. So we're going to have the event for half day. So it's going to run from 8:30 a.m. to 12:30 p.m. And for those who are wondering whether we are giving away CPD points or not, yes, we have already applied and 2 BQSM CPD point has already been approved. The participation fees for this event is RM50 per person, and the details of how you can make payment is in the QR code after you scan that QR code. So the focus of the webinar topic would be on the Construction Design and Management CDM Regulation 2024, which marks a major milestone in Malaysia construction landscape. So it has reshaped professional responsibilities, formalizing implementation processes, and promoting digital integration to improve safety and project collaboration. And this webinar offers participants with the opportunity to learn directly from industry experts on the regulatory updates and discover how emerging digital technologies can redefine practices and drive the future of construction management. There are lots of reasons why you need to attend this CPD event. Number one, you should be able to stay ahead of regulatory changes with a first-hand insight into the CDM Regulation 2024. Secondly, you could discover digital innovation in BIM and analytics that enhance safety, efficiency, and also collaboration. Last but not least, you can future-proof your career by gaining skills that align with Malaysia's digital transformation in the construction. So the theme of the online webinar is Safety BIM Data Analytics, and we have 3 speakers or 4 speakers, and their topics are shown as on the screen right now. So first, we have Dr. Muhammad Fairuz Abdul Rahman, is the Deputy Director, Construction Safety Division, Department of Safety Occupational Health Malaysia, and he is going to deliver his presentation on redefining professional duties under CDM Regulation 2024. Our second speaker in our lineup is Dr. Nur Nilam Sari Mat Yusof. She's a BIM Research Group industry affiliated member, and she's going to present on the process protocol for the implementation of CDM Regulation 2024. And our third and fourth speaker are Mr. Akmal Zulkifli and Mr. Shamil Shaharin. So they are the founding partners of SNA Data Services, and they are going to deliver their presentation on BIM-powered data analytics for quantity surveys and construction technologies, transforming safety and collaboration in the evolving CDM environment. So, without further ado, please scan the QR code, register yourself for the event. Details on how you can make the payment is in the Google form on the QR code shown on the screen. Thank you.